All right, so here we're going to look at our OR inequalities. These are a couple of your special conditions, and then our regular OR inequality will also be included. So the first one we have is x is greater than 2 or x is greater than or equal to 7. So you saw one like this yesterday. So we have x is greater than 2, and we have x is greater than or equal to 7. So remember that when we're looking at ORs, we're looking at their union. We want to know where it's true for at least one of them. So if everything that is greater than 2 is also greater than or equal to 6, we're going to drop this one underneath. So it's the opposite of your and. And you want to look at where they are both intersecting, so where they overlap, whereas for your ORs, they just exist separately, and then if one happens over the other, you drop the one that's included within the other one. This one's just going to be x is greater than 2. Because if only one has to be true at a time, if you're greater than 2, you're always going to be greater than or equal to 7. So we only have to keep one of them. All right, next let's look at x is less than 5 or x is greater than or equal to 2. So remember, ORs, it only has to be true for one at a time. So we have x is less than 5. And we have x is greater than or equal to 2. Notice how they overlap and they keep going in both directions. So since this is an OR, basically we're saying that the entire number line is going to be covered. So we don't need these circles or anything. We just need one constant line because this is going to be an infinite solution. So because it's an OR, and we want to take everything that they share and everything they don't share, we're just basically bringing it all together. It covers the entire number line, making it an infinite solution. So any number could be less than 5 or greater than or equal to 2. So let's test some of them. 1 is less than 5. Good, it works for one of them. 4 is less than 5 and is greater than or equal to 2. So it works for at least one of them. 6 isn't less than 5, but it is greater than or equal to 2, so that works for all of them. So if you even wanted to do that, you could test one to the left of the original dot, one within it, and one to the right of the original dot to show that everywhere it's satisfying at least one of them, so that's how we know it's an infinite solution. All right, our last one, we have x is less than or equal to 3, or x is greater than or equal to 8. So we have less than or equal to 3. And we have greater than or equal to 8. So this is going to be our most traditional OR statement. That should be a little further over to be right above 8. All right. So this is the one you'll see most often. But remember, if they are going towards each other and they cover the entire number line, it's an infinite solution. If they're going in the same direction, you drop the one that's included underneath.